Well, Surgeon Dr. Ahmed Gilani is there, and today I am here to simplify the concepts of the fluids and electrolytes on a surgical floor. I will discuss the practical implications. I will not discuss about the boring too much detailed theoretical aspects. So let's start. So first of all, this slide is very much compulsory whenever you discuss the fluids and the electrolytes. And remember always, the water gain will be equal to the water loss. So from where you gain the water? You gain water from the metabolic water, that's the 200 ml. You ingest food and it contains the water 700 ml, and you ingest also liquids and it contains 1600 ml of the water. So the water losses, it is lost in the form of GIT tract, especially in the stools, almost 100 ml. Then it's lost from the lungs through respiration, that's the 300 ml, and from the skin 600 ml is lost per 24 hours, and from the kidneys in the form of urine it is lost almost 1500. So this is the urine, this is the stool, and this loss is the insensible loss. Okay, so the water gain should be equal to the water loss. This is the very basic concept. So on the surgical floor you give the maintenance fluids, and the maintenance fluids, they are those which when administered they maintain the urine output up to 0.5 to the 1 ml per kg per hour. So approximately for a 70 kg person it becomes 40 ml per kg per hour for a 70 kg person. Okay, and this thing you will remember and it will be helpful in the next sections of our slides. So moving towards the next slide, whenever you talk about the maintenance fluids, you will also talk about the electrolytes, and most common electrolytes which we talk about, that's the sodium, that's the 1 millimole per kg per day, and potassium also 1 millimole per kg per day. You have to replace it, you have to maintain, that's the maintenance fluid. Then you will also talk about the dextrose, there it will be 100 to 150 gram per day, and this is very small amount. What you say, it will provide nutrition? No, definitely it will not provide nutrition. It's for the brain. And summarizing the things, the maintenance fluid will be equal to total intake is equal to total output, and total output, it's in the form of stool, urine, and insensible water losses. So moving towards the next slide, electrolyte deficit. So you have got two methods to calculate the electrolytes deficit. First method is the formula method, which is the accurate method, and other method is secretion losses, and I will discuss that's to somehow it's a crude method. So first of all we are going to discuss about the formula method. So to calculate the sodium deficit, you will use the formula total body water multiply weight in kg multiply by the sodium desired minus sodium measured from the serum electrolytes, and total body water in male it's 0.6, in females its value is 0.5. So it will not make a lot of difference, so you can use the both of the values. In the same way, the potassium's deficit, it will be equal to 0.6, that's the total body water, multiply the body water in kg, and multiply by potassium desired minus potassium measured from your lab values. So this is the formula which you have to remember. In case of potassium, sometimes we also use 0.4 instead of 0.6. So this does not makes a lot of difference. So don't be conscious about this thing. So moving towards the next slide, we are going to calculate the electrolytes deficit, and now we are calculating this sodium deficit. Here you can easily see that the formula is total body water multiplied weight in kg multiplied by sodium desired minus sodium measured. So almost it will come 0.6, that's the total body water, that's the constant value. 70 kg it's the weight of the patient, and our desired value of the sodium is 140 minus the calculated sodium, that's the 133. It will be from the lab values. You have to calculate this thing, and when we are using the calculator to calculate these values, it will become the 252 millimole, that's the sodium deficit. So to make the sodium from 133 to 140, which is our desired value, we have to give 252 millimole of the sodium. So that's the sodium deficit. In the same way, we are moving towards the next slide. In the same way, we have explained the calculation of the potassium deficit, sorry to say. Again, total body water, that's the 0.6, then body weight in kg, and then potassium desired minus potassium measured. So putting the values in a 70 kg person, for it's our desired value, and 3.1 suppose it's our calculated value, and putting the values and using the calculator, and it will become 37.8 millimole. So you have to use 2 ampoules of the potassium to fulfill this deficit. Now moving towards the next slide, and we can also use the crude method, that's the secretion method. Suppose I have put the Ng in the patient, and he has lost 1 liter. Definitely in the Ng only 2 things will be there. One thing is saliva, other thing is the gastric juice, and definitely if we calculate the 70 plus 15, so the patient will lose 85 milliquintal of the sodium if he has lost 1 liter in the Ng. And meanwhile, in the same way, you can calculate the other values also. So this was very simplified way to give to the concept that how we can calculate this deficit with the help of secretion method. So you can memorize this table. So now this is the most important slide, the composition of the various IV fluids. So you must have on the fingertips. Most of the times Hartmann and Ringer it's considered as same, but there is slight difference, like the sodium content it's 131 in the Hartmann and 130 in the Ringer lactate. Same way potassium it's 5 in the Hartmann, and in the Ringer lactate it's 4, and calcium it's 2 in the Hartmann solution, and in the Ringer lactate it's 1.4, chloride 111 in the Hartmann and 109 in the Ringer lactate, and lactate component it's 29 in the Hartmann and 28 in the Ringer lactate. So you can consider these fluids as the same fluid because there is very slight difference in their composition, but in the normal saline you will find only 2 things, 154 sodium and 154 chloride, and 5% dextrose. It will contain only 50 gram of the dextrose in 1 liter, and Hemaxil it will contain 145 sodium, 5.1 potassium, 6.26 calcium, and 145 chloride. So you must remember the composition of these fluids to solve different scenarios. So moving towards the next slide. So first slide, in which the preoperative fluid management. Preoperative fluid management, you will look for the three things, and what those things are there. If you are going to perform the laparotomy or any surgery, so you will definitely think about the three things. First is the HB, second is the hydration status, and third is the electrolytes. And it should be corrected before surgery whenever possible to optimize the patient. And in case of the HB, if you are transfusing the packed cell, it will raise the HP by 0.8 to 1 gram per DL in a 70 kg patient. And the hydration status, you will monitor with the CVP. That's the accurate method. And the another method, that's the urine output. You will put the Foley's catheter and you will monitor the urine output per hourly. In case of electrolytes, the same formula which I have discussed in a previous slides, you will use it. That's the total body water, multiply the water in kg and into desired sodium. In the previous slide, I have used the value of 140, and the patient sodium by the serum electrolytes, which will you calculate. That in the previous slide I have used the 131, and total body water 0.6 for males and 0.5 for the females, so it will not make a lot of difference. Meanwhile, you have to calculate the potassium deficit and you have to replace accordingly. So moving towards the next slide. Then you have got the intraoperative fluid management. You might be thinking, most of the time we are doing the surgeries and we don't bother about the intraoperative fluid management. So it's the task of the anesthetist. So you will see this in the anesthesia notes. Definitely you will use the maintenance fluids and blood loss. 1 ml blood or a colloid per 1 ml loss, or 3 ml crystallite per 1 ml blood loss. So if you are using the colloids, then 1 is equal to 1, and if you are using the crystallites, then 3 is equal to 1. And you have also definitely calculate the third space losses, and you will replace these losses accordingly. And in case of the third space losses, we have simplified the things, that if incision is small, the patient will loss 1 to 3 ml per kg per hour, and 3 to 7 ml per kg per hour for the moderate procedures like the medium incision, and 9 to 11 ml per kg per hour for the major procedures, and in which you have given the larger incisions like exploratory laparotomy. And you will also calculate the ongoing losses, like from the NG, stool, he is passing the stool, bile, and the pancreatic secretions. So intraoperative fluid management, you will look for these things very consciously. We have given the scenario that 25 years old female patient undergone laparoscopic cholecystectomy, and the operative time, it was 2 hours, and we have given a command to calculate the post-operative fluids. So now proceeding. We have given the information that the weight of the patient is 45 kg. Okay, and the pre-operative the status of the patient, in which we see about the HB level, we see about the hydration and sodium and potassium, it's normal. Okay, and the per-operative status, maintenance fluid, it was 40 into 45, the weight is 45, and the value, it comes out to be 1800. Definitely it's for the 24 hours, and we will divide it by the 24 hour to get the fluid requirement in 1 hour, and the operative time was 2 hours, so we will multiply it with the 2. the value will become 150 ml. Okay, and third space loss, we are considering it as a moderate incision, and definitely in the previous section we have studied for the moderate incision it's 3 to 7, so we are taking the value 7 ml per kg per hour, and we will multiply it with the weight of the patient, and as we require for 2 hours, so we will again multiply it with the 2, so 630 ml will be there, and ongoing blood loss it's nil, and the blood loss it's also nil. So the total fluid per operative 630 plus 150, it almost comes out to be 780 ml. That's the per operative fluid he will require. Now we have given the command of calculating the post-operative fluid. So for that purpose you must know the duration of the NPU. In this case we will keep the patient NPU for 4 hours. Okay, and the maintenance fluid, it's the weight into 40, definitely it will come 1800, and it's for the 24 hours, and we will divide it by 24 to get the fluids in 1 hour. As we require the fluid for 4 hours, so we will multiply again that value with the 4, and it will come almost 300 ml. So the post-operative fluid will be 300 ml in this patient in 4 hours, and the electrolyte sodium, definitely its value is 1 milliequintal per kg. So for a patient of 45 kg it will be 45. We will divide it by the 24 to get the value in 1 hour, and we will multiply it by 4 to get the value in 7.5 in 4 hours. But again the golden rule, it should be low in sodium, there should be no potassium, and it should be low in volume. So finally after the roundabout we will give the 280 ml in 4 hours, and we will write it down on the treatment chart of the patient as injection or infusion ringer lactate 300 ml IV at 33 drops per minute. Okay, so it will be appropriate for our patient. Now finally we are making the things more complicated for you, and again there is one more scenario. Now the 45 years old male patient underwent the Whipple procedure, and the operative time was 6 hours, and the pre-operative parameters, they were normal, and you are asked to write his post-operative fluid. So now proceeding towards this scenario, this is to somehow complicated. The information we have given that the weight of the patient, it's 40 kg, sorry, it's 60 kg. So the weight of the patient is 60 kg, and the pre-operative status like HB hydration, sodium, potassium, they were totally normal. Okay, and the per-operative status, here we will focus the maintenance fluid. We will multiply the weight with the 40, it will become 2400 ml. Definitely this 2400 ml, it's for the 24 hours, and we will divide this 2400 by 24 to calculate the fluids in 1 hour. And as the operative time was 6 hours, and we will multiply it with the 6, so it will become almost 600. Okay, and the sodium, definitely 1 milliequintal per kg. So in a patient 60 kg, so its value will be 60 divided by 24. for 1 hour, and we will multiply it with the 6 to calculate the sodium to be given in 6 hours. That's the 15 milliequivalent. And the third space last, as it's a very large NCN. So in the previous slides I told you that its value is 9 to 11 ml per kg per hour. So we have taken the value 11 and we will multiply 11 with 60 and with the time, that's the 6 hours. So we will be having the value 3960. Okay, and ongoing classes in the NG in the 6 hours, it's 500 ml. So in the NG the fluid is 500 ml and the sodium it's 35 milliequivalent. In the previous sections I have told you that you can use the crude method by secretions. You can calculate the electrolytes deficit. So blood loss in this procedure was 900 ml. Okay, so proceeding, the total fluid requirement, that's the 5060 ml, and sodium it's 50 milliequivalent, and the blood loss it's 900 ml. And due to certain reasons blood was not available, only one blood was available, so we have given the 450 ml blood, and we have given the fluid ringer lactate 3 liter, and we have given the normal SNAN 1 liter. So 500 ml is deficit from here and 450 ml is deficit from here. So I have mentioned this thing because I have to replace this fluid in the post-operative period. So that's why I have mentioned this thing here for your simplicity. So here, finalizing the things, total fluid required, it was 5060 ml, and sodium 50 milliequivalent, and blood was 900 ml. And as we have given the ringer lactate 3000 ml, normal STAN 1000 ml, and the whole blood we have given the 450 ml. So deficit is total 1060 ml, and injection whole blood or infusion whole blood 450 ml. So now we have to calculate the post-operative fluid, and we will keep this patient NPO for 4 to 5 days, but 6 hours they spent in the operative period, and now we will calculate the fluid for 18 hours, and after that from the next day from 8 we will calculate from 8 to 824 hours. But now 6 hours have been passed, and we will calculate the fluid from the 2 to 8 for 18 hours. So the post-operative NPO required is 24 hours, and the maintenance fluid, we will multiply the weight with 40, it will become 2400. Okay, definitely 2400, it's for the 24 hours, and we will divide it by the 24. So we will get the value for 1 hour, and we will multiply that value with 18, and our value it will be 1800. And electrolyte sodium 60 divided by 24 for 1 hour, as we have to give it for 18 hours, so we will multiply it with the 18, and it will become 45 milliequivalent, and the per operative deficit was 1000 ml and 450 ml of the blood. So we will replace it in this post-operative period, which was deficit in the per-operative period. So with this, finally hope you have understood something. If you have understood something from our videos, then do subscribe our channel Surgeon Dr. Amar Gilani for more educational content. So thank you so much. Do subscribe our channel by clicking on the red button below, and don't forget to press the bell icon also.